definitions for you, just to make it a little quicker. These are some words you need to know. Radical. Actually, let's just go up here. Let's say you have something like this. This whole thing is called a radical. The square root is actually called a radical, and the number underneath it, you'll see sometimes it's called the radicand. I don't always use that word, but that is the proper definition for it. Okay? And the little square root sign is actually the radical as well. It's called a radical. So a radical expression is an expression that contains a radical. Could be a square root, a cube root, a fourth root, a fifth root, and so on. Anything that has that little thingy in there. So a square root would look like this. You could have a cube root of 4. You could have the fourth root of 4, etc. So if you see something like that, it's called a radical expression. A radical function is when the independent variable is in the radicand. Oh, I just told you what the radicand is. That's the stuff underneath the radical sign. So x is the independent variable. Let's put that in parentheses here. And y is the dependent, right? Because y depends on x. Y depends on what x is. The poop depends on the food, doesn't it? Y'all remember what I'm talking about when I say that, right? Okay. All right. Eat a beet, and your poop looks a little different. Anyway, it's the same thing. Whatever goes in affects what comes out, okay? All right. Square root function. If the radical is a square root, it's called a square root function. Obvious. Parent square root function. So this is the most basic function for square roots, and it looks like this. Y equals the square root of x. That's it. There's nothing being multiplied by the square root of x. There's nothing being added to it. There's nothing being subtracted, divided. That's it, the basic parent function. And the graph just looks like this, and we're going to draw lots of those, and I'm going to show you what those are. It's not shifted up, it's not moved left, it's not moved down, it's not flipped over, it's just that. Okay? All right, graph the function. That's one thing we got to do. Identify the domain and range. That's the second thing we have to do. And compare the graph with the graph of y equals the square root of x. Okay, so we have to do 3 things. Actually 4. I want to draw that too. That's number 4. I always want to draw that, so I can compare it. So actually, let's start with number 4. We're only going to do this once. We're going to make a little table of values for the parent function. If x is 0, 1, well, let's say, okay, what's the square root of 0? Y is 0. 0 goes in, 0 comes out. Thank you, Clark. If x is 1, what's the square root of 1? 1. 1 goes in, 1 comes out. Now, I don't want any decimals, so what would be the next best number to use?
4.
4. What's the square root of 4? 2. These are the easiest points to graph, and you're going to memorize them because that's your parent function. You're always going to draw the parent function. Pardon me? If x is 4, what's the square root of 4?
Oh, it's if you don't want a decimal.
If you don't want a decimal, no decimals for your graph. Okay? So let's plot these points. 0, 0, 1, 1. I picked 4. That was the easiest one to plug in. Yeah, that was the easiest number. And then over 4 up 2. This is your parent function. I'm going to write it right on there. You're going to draw that on every single one of these graphs that we do today. 0, 0, 1, 1, 4, 2. 0, 0, 1, 1, 4, 2. Okay, you'll get pretty good at that. All right. So now let's graph y equals 2 times the square root of x. Okay, I'm just going to pick some easy x values. We could do the same ones. What is the square root of 0 is what?
0.
Times 2? Did I go over too far? I did, didn't I? 4, 2. Yeah, there we go. Okay, 4, 2. All right. Okay, so then let's pick another easy one. If I plug in 1 for x, what's the square root of 1?
2.
Square root of 1 is 2?
1.
1 times 2, my output would be 2. Then that next easiest would probably be to do 4 again. You're not always going to use those, but for this one it's easy. What's the square root of 4? 2 times 2, so my output would also be 4. So let's graph those. 0, 0, over 1 up 2, over 4 up 4. So what would you
Well, that's
say?
-2. You didn't times it by -2.
What?
Y equals -2 square root of x.
Oh, I'm doing this one right here.
Oh,
Okay? Thank you, though. All right.
okay.
We're getting there. Okay, so what would you say kind of happened to that graph? What happened to it? How does it look different?
It's higher.
It grew. Or could we say it stretched? That's the word we use. The y values got bigger, so it climbed faster. We call it a stretch. Okay, so I'm going to say y equals 2 times the square root of x is a stretch of y equals the square root of x. And if you can't remember that word stretch and you say grew, that's fine. Y equals the square root of 2 times x. 2 times the square root of x is a stretch of y equals the square root of x. All right, and the last thing we have to do, we did the graph, we did the comparing. Let's identify the domain and the range. Domain is the x values of this graph. What are the x values of that graph? They're all greater than or equal to what? 0. If I pick a point here, 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 they're all greater than or equal to 0. They're not going to be negative. Can't stick a negative number in here, can I? Can't stick a negative in for x. So it's x is greater than or equal to 0. The range is the y values. What are the y values of this graph? They're all greater than or equal to?
0.
Yeah, there are no negative y values, are there? So they're greater than or equal to 0. So we did all 4 things. The next one will be quicker, okay? All right, so the first thing I want to do, ooh, notice, this was positive, this is negative. Does anybody have any ideas in their head what might happen?
Everything's going to change. It'll be upside down.
Thank you, Owen. It is. Okay? Let's start with the parent function. Memorize these points. 0, 0, 1, 1, 4, 2. There's my parent function. Y equals the square root of x. Let's make a table. Y equals the -2 times the square root of x. I think I can use the same easy values. If I stick 0 in for x, what's my output going to be? 0. If I stick 1 in for x, what's the square root of 1? Times -2. So I'm going to get an output of -2. If I stick in 4, which is an easy one to work with, square root of 4 is 2, times -2 is -4. Oh, look what happened. My y-coordinates are now negative because I'm multiplying by negative. So let's graph those points. 0, 0, over 1 down 2, over 4, down 4. Oh. Look at that. So what caused that to happen?
Negative.
The negative. All your y values became negative. So we're not done. Come on now, you're not flipping the page already. We haven't done half. We've only done half of it.
We did do that.
We did the parent function. We graphed the function. Now we have to do, let's do domain and range. We could do domain and range right now. What are all my x values? They're all still greater than or equal to what?
0.
Yeah, any place on this point, the x coordinates are greater than or equal to 0. The y values any place on this graph are all what?
Less than or equal to 0.
Less than or equal to 0.
Would the blue be y equals -2?
Yeah, it is.
Okay.
Yeah.
So I was used to you writing it right next to the line.
Okay.
When you do the range, you just do the blue one, then, right? You don't do the other one.
Right.
Okay.
Yeah. And then the other thing is, remember on here you said that this was kind of a stretch? Well, this is also a stretch and a what? Flip. Because you have the 2 in there, but then you also have the negative. So you have 2 things that happen. You have a stretch and flip. That's good enough. Stretch and flip. If I could spell flip. Flip. Stretch and flip. It's fine for now. Okay, a few more. Alrighty. So we already know the parent function. What are the points of the parent function?
4, 1, 1,
0, 0.
4, 2.
4, 2. Don't just memorize it. Just think if I stick 4 in, I'm going to get out 2, right? Okay, so 0, 0, 1, 1, 4, 2. Okay, there's the parent function. We got to do the same thing now. We got to graph this. I'm going to write parent function on here so I know. That's what that is. Anybody have any ideas before we graph? What's going to happen to this parent function if I subtract 1? What do you think? Just a guess.
Go down 1.
It is. It's going to go down 1. He's right. Let's see what happens. Y equals the square root of x minus 1. Okay. I think I can use those same numbers because I'm not going to have any decimals. I'm still going to be able to use 0, 1, and 4. So if I stick 0 in, what's my output going to be? -1. If I stuck 1 in, what's the square root of x? What's the square root of 1? 1. Take away 1. So my output, my poop, is going to be 0. If I stick 4 in, what's the square root of 4? 2, take away 1, what's my output? 1. Okay, now let's plot these points.
Wait, I'm not.
Let's talk about the shifting before we actually write down the domain and range. Look what happened to all my points. What happened? I went down 1. That's what happens here when you just take away 1 from the function. Okay? So it shifted down 1. However you want to write it. You can even do an arrow. In Algebra 2, sometimes we just do that. Down 1. Okay? All right, so let's talk about the domain now.
Did you put the y equals square root of x on the pink? What would
No.
you put on the blue?
The blue is this function right here. See, blue is this function. Pink is always my parent function today. Okay, domain. Again, what are all my x values anywhere here? They're all going to be greater than or equal to what? Yes, x is greater than or equal to 0. Any point on this graph, x is greater than or equal to 0. And y is greater than or equal to what point here? Yeah, this is the lowest point on the y-axis, right? You don't always look at the y-axis, but that's how I gear it towards. So y is greater than or equal to -1. Okay, you do this one. Same way. You try it. Does anybody have a guess what's going to happen? It's happening underneath the radical. So that's going to cause a different kind of shifting. Does anybody have a guess?
Probably to the left or right.
Is that what you were going to say? Yeah. When it was outside, it goes up or down. When it's inside, it goes left or right. Okay? So we're still going to draw that parent function. You should be pretty good at that. 0, 0, 1, 1, 4, 2. They all look a little different because the scale's a little different on these graphs. That's the parent function. Alrighty, now let's make a little table. We have to pick some different values here. We have to consider some different values because we're going to get a decimal if we use our regular ones. We don't want a decimal. So what, well, yeah, but look at our x values don't go very high.
First responders to room 481, please. First responders to room 481.
So we have negative up to -4 and we have up to +4. What do you think some x values would fit that would not give me a decimal?
2.
What if we did 2?
0, 2,
If I do 2, I'm going to get 4 under here, correct? Sometimes you have to think about it. So I'm going to do +2. You have to think about what won't give you a decimal. When you plug in 2 for x, 2 plus 2 is 4. What's the square root of 4? So my output would be 2. There's 2 more that we could use that actually fit on this x-axis. What else could we use for x? That won't give me a decimal.
4.
No, because 4 plus 2 is 6. When I take the square root of that, it gives me a decimal.
7.
No, too big. Doesn't fit on this. Yeah,
Negative 2.
right on. -2. If I do -2 plus 2, I get 0. What's the square root of that? Now there's one more.
It's plus
0.
Right on. Parker said, what about -1? That fits on my x-axis. -1 plus 2 is 1. What's the square root of 1? 1. Now I can fit those points on my graph. So sometimes you have to think about it a little bit. So graph those points.
Whoa, tricky.
So the arrow would still go that way every time.
Well, you just follow your dots.
Why did you go?
You wouldn't go this way because your dots aren't that way, correct? Yes, it does. All right.
You're supposed to go left 2 and up 2, correct?
No.
No? Then what do you do?
What happened each time? What happened from this point to this point?
1, 2.
What about this point? Left 2.
I mean, on the blue.
Left 2. So every single time we went left 2. Isn't that odd? Because this is a plus. You wouldn't think that, would you? But it is. It's just the opposite. So we went left 2. Yes.
I didn't fill out the blue yet, so
We'll fill out the blue.
wouldn't it go left 2 and up 2, and then
No, Philip.
Just use your points. Just use your points. And you'll get these.
that's when
You wouldn't use the points.
If you graph these points, you're going to get this graph. It just goes left 2 each time. Think about it. Let's do the domain. And the range. Just keep thinking about it. I don't want you to stop. If you plot these points, Amelia,
Yeah, so-
you're going to get that graph. This one here, this one here, this one here. So what's the domain? What can all my x values be? Yeah, they can't be any less than that. They're going to start here at -2. So they can be x is greater than or equal to -2. Any point on this graph. X is greater than or equal to -2. How about y values?
Greater than 0.
Greater than or equal to 0. Hold on to it. I'll get to you. All right, we got to do this last one, which has kind of got everything. Let's graph the parent function, and then we're going to talk real quick. 0, 0, 1, 1, 4, 2. Parent function. What do you think is going to happen to this graph?
It's gonna shit everywhere.
What's the 2 going to do? Remember, that was on the front. What did the 2 do? Stretch. It makes the y's double. Okay? What's this 2 going to do?
Make it go up.
Up 2. This is kind of tricky. What's this 1 going to do?
Make it go back 1.
It goes to the right, because when it was plus, it went to the left. This is going to make it go to the right one. So let's just make a table. Again, we got to be kind of thoughtful about our x values. I could only come up with 2 that would fit on this x-axis and not give me a decimal. So look underneath here first. What can I stick underneath here that won't give me a negative number and won't give me a decimal?
3.
3, yeah, but no, the square root of 2 is a decimal.
1.
2, 5.
Oh,
I was just gonna say that.
Try 1. What's 1 minus 1?
0.
0. 0 times 2 is 0 plus 2. So what's my output going to be? Do you see it? Okay, there's one other number I could come up with. 2 would work. Let's do 2. There's another one I could come up with too. 2 minus 1 is what? 1. The square root of 1 is what? 1. Times 2 is 2. Plus 2, 4. There's one other number. I know, but there's another one. 5.
What? Make 6.
Oh, let's see. 5 minus 1 is 4. Square root of 4 is what? 2 times 2 is 4. 6.
So when you add 2, like,
After you do all this is multiplication, so you have to do all this first. That's following order of operations.
what, so you,
You do the square root first,
alright.
multiplication next, and then addition is last.
Wouldn't it be 8, not 6?
Mm-mm.
It's 6, but
5 minus 1 is 4. Square root of 4, 2
2 is
times 2. You have to multiply first, okay? It fits. All right, let's graph that. Over 1, up 2. Over 2, up 4. Over 5, 1, 2, 3, 4, 5. 6. Be careful, this is your starting point. You don't go below that. That's your starting point. That is the smallest x value I can stick in there and not have a negative. That's your starting point. So it's kind of hard to look at the graph and say what happened, but you can look at the equation and say what happened. This 2 out here causes a what? Stretch. So it was a stretch of 2.
Okay, just write stretch.
You should write stretch of 2, maybe. What does that cause it to do? That caused the up. Up 2.
Wouldn't it be because of the plus?
Yes. And then the minus 1 caused it. Everything went over. All the x values went over 1, didn't they? So they went to the right 1. That's what happened to that graph. That was like the grand finale, the doozy, but we still have to do domain and range.
X is greater or equal to 20.
So all my x values, they start at 1, and they're anything bigger than 1. My y values start where? At 2. My y values start at 2. Okay?